right, ladies and gentlemen, here are the second part of our Section 7 notes here. This is, again, involving quotient, so it's basically going to be kind of a continuation of what we did in the last video. Now, this one is kind of expanding upon that and kind of dealing with kind of more special cases and kind of other special exponent properties. Starting with negative exponents. All right, so basically, when it says it says that an n to the negative n is the reciprocal of a to the n power. So what does that mean? So it basically means is that if you have the negative exponent, you basically just move it. You basically just kind of treat it like a fraction and flip it. All right, you basically just take the thing, move it down here. That's the end of the negative n right there. Okay. Basically what it means is that, and this is kind of how I like to think about it, literally you take a negative exponent, so basically kind of think about it like this, say you got like the negative exponent up here, you take that negative exponent, you move it down to the bottom, and then you finally get the positive exponent. And similarly, if you have the negative exponent, this is just, say just some random negative exponent, you take that, you move it to the top, you get a positive exponent on top. So that's basically what it is. You take negative exponents and you basically just move them to either the bottom of the fraction, or for some, if they're on the bottom of the fraction, you move them to the top. So let's go ahead and do this one here. So we have c to the negative 4 power here. We can treat this as c to the negative 4 over 1. What we're going to do is literally just take c to the negative 4, move it down here, and once we do that, we get rid of everything on the top of the fraction. We're just left with a 1, and then it's over c to the now positive 4 power, all right? 1 over c to the positive 4 power. 9 to the negative 2 power, it's essentially the same thing. Even if it has a number, it's still the same process. 9 to the negative 2 over 1, I'm going to take this, move it to the bottom of the fraction, turn that positive when it moves to the bottom. It becomes 1 over 9 squared, which technically is also 1 over 81. Okay? Now, for the times that it's on the bottom here, I got x to the negative 5th power. I take this x to the negative 5th power, and all I'm going to do is literally move it all the way up to the top here. And that means it's equal to x to the 5th power. Technically x to the 5th power over 1, but if we have any fraction over 1, we don't even have to write that. So it's essentially that. Now we got 8 to the negative 4 power over 8 to the negative 6 power, okay? Now, if you want to go ahead, if you want to go ahead and do this minus that, you can do that. Again, I don't like dealing with negative exponents, so let's just go ahead, clean it up a little bit, and then go from there. So I got this 8 to the negative 4 power here on the top of the fraction. What I'm going to do is going to move it to the bottom of the fraction, turn that 4 to a positive. But I also have this 8 to the negative 6 power. I'm going to take that, and like I did right here, I'm going to move it to the top of the fraction, okay? And so if I flip this, so basically what I'm doing is I'm flipping those around and making the exponents positive, which means it will equal now 8 to the 6th power over 8 to the 4th power. And then from there, what we can do is we can now simplify out these exponents. I do 8 to the 6 over 4, that just turns into 6 minus 4, that turns into 6 minus 4, which is 8 to the squared, which is equal to 64, okay? All right, 1 over 2 to the negative 3rd power. Again, we're taking this negative 3 right here, moving it up top, and then it turns into 2 to the 3rd power, which equals 8. Again, self-explanatory there. This one right here, I got x over y to the negative 3rd power. This y to the negative 3rd power, I can already see is negative, so I'm going to move, it's on the bottom, so I'm going to move it up top here, and it's going to turn into a positive exponent. But this x is not a negative exponent. It actually has, it has the exponent of 1, but it's a positive exponent, so it's not going to move anywhere. So it's going to stay up the top there, and the y is actually going to join it. So it's going to turn into x times y to the 3rd power, technically over 1, but again, you don't even have to write that. It just turns into x times y to the y cubed, okay? Then for this one, we got b to the negative 3rd power over a squared. What I'm going to do is I'm going to take this negative exponent. I see that negative exponent there. I'm going to move it automatically to the bottom there, okay? But again, this squared right here, that's a positive exponent. So I don't have to move that at all. That's going to stay on the bottom. That a squared is going to stay on the bottom, and that b to the negative third is going to join it and turn it into a positive third power. All right, turns into 1 over a squared times b cubed, okay? Now for this one here, now, hey, we're throwing a couple of different variables at you, both and 2 on top, 2 on bottom, okay? So hey, let's move them around. Let's see what we can do with these. Let's start with these negative exponents here. I got x to the negative 4 and then x to the negative 7, okay? Both of these are going to switch, so I'm going to switch this one to the bottom here, switch this one to the top. They turn positive when they switch sides, so it turns into x to the 7th power. And then the y to the 5th, that's positive. These y's are positive, so they're going to stay where they're at. They're going to stay. The y to the 5 is going to stay on the top. The y to the 9 is going to stay on the bottom. X to the negative 4 moves to the bottom and just becomes x to the 4. And then y to the 9th stays on the bottom. Now when we simplify it out here, what we're going to have happen is it's going to turn to x to the 7th over x to the 4th. I just find my similar bases, x's on top and bottom, y's on top and bottom, and I simplify. 7 over 4, x7 over x4 turns into 7 minus 4, which is x to the 3rd power. I'm actually going to do a little bit of changing here. I'm going to write it kind of up here, x to the 3rd power. Now this one's a little bit different here. We have 5 minus 9, which technically gets us a negative 4, all right? Y to the negative 4 power. But what we remember is that we take this in y to the negative 4 power and we move it to the bottom here, which gets us x cubed over y to the 4th power. All right? Now that's something to kind of keep an eye on, is when the exponent is bigger on the bottom instead of on the top. Because if it's bigger on the bottom, it's going to end up moving to the bottom itself. All right? And we'll have a few more examples of those as we go here. All right, now the next few examples here deal with 0 exponents. All right, now 0 exponents are actually really nice, and they're actually they're a little bit more straightforward than negative exponents in that any number with a 0 exponent is just the number 1. Like you could literally plug in, 13,715,388 to the 0 power. It still equals 1. Okay, any number to the 0 power. Any variable to the 0 power is equal to 1. Now what's nice about this in kind of our bigger simplification problems is that if you have a 0 exponent, you can basically just cross it out. Make that term, cross it out, because that term equals 1, and I'll even show you over here. Quick example here, c to the 0 power equals 1, same as it is right here, okay? These ones right here. Now technically, what this becomes in a technical sense, which is why we can cross it out, x to the 3rd power times 1 over 1 times y to the negative 3rd power. But do I really need to write a multiply by 1? No, I don't. So what I can do is literally just cross them out, turns into x cubed over y to the negative 3rd power. And then what's going to end up happening with that is I'm going to take this y to the negative 3rd power, move it to the top here. And then it becomes x to the cubed times y to the 3rd power, all right? I go over here, I got y to the 0 power. I automatically cross that out, get rid of it. Write out my new fraction. I get x over x to the 4th power times y to the negative 3rd power, all right? Now I see my negative exponent. I'm going to take that and flip it, move it to the top, all right? If it's on the bottom, I move it to the top. I flip it to the top, it turns into a positive exponent of 3, so it turns into this x times y to the 3rd power over x to the 4th power, okay? And then from there, I still have these x's that I can simplify out. Now, I'm going to show you a little bit of a little trick here, and I might even write it out here. But I'm going to still do my big exponent minus my little exponent. Now, where is my bigger exponent at? Well, it's on the bottom. So whenever I simplify that out finally, my x is going to stay on the bottom, all right? It's wherever the bigger exponent is, it's where it's going to end up. So it's going to be x4 minus 1, which is x to the 3, but it's going to end up on the bottom there. X to the third stays on the bottom there, okay? And then this last one, oops, excuse me. This last one, you know, the whole thing is to the 0 power, just equals 1, all right? Don't get tricked on some of those, all right? Sometimes they're going to give you like a big problem and raise it all to the 0 power. Don't get tricked on those, all right? Anything raised to the 0 power is just the power. It's just the number 1, all right? Oops, sorry about the bell there. Now, again, I'm kind of going to. I want to kind of show again the rule of exponents here. I'll kind of go over some of this stuff right here. So, remember. So this is kind of a shorthand rule. Now, if you want to do 1 minus 8, get to the negative 7th power, good. I like this rule a little bit better because it just kind of cuts out dealing with negative exponents. But remember, if you have the exponent bigger on the bottom, then eventually, one way or the other, x eventually will end up on the bottom. All right, x, because you do 8 minus 1 gets you 7. X to the 7th ends up on the bottom. Eventually, if it's bigger on bottom, exponent is bigger on bottom, it will move to the bottom of the fraction. It will not stay on the top there, all right? All right, so we have a couple bits and notes here. You know, you could fill all this stuff out. You know, it's just a bunch of words. I'm actually going to kind of show you guys a few of these examples, and then we will kind of go from there. I'm going to pause the video real quick. Oh. A little bit too far there. All right, so now we're doing some kind of bigger examples here, and I kind of have a checklist up here. You might not be able to see like parts of it, but I do have a checklist up here to kind of go through some stuff here. So let's go through some of this stuff here. All right, so went too far. So example number 1 here. First things first. Any 0 exponents you have, just get rid of. Now. This one's nice. We have this whole parenthesis raised to the 0 power. Cross that out. Anything raised to the 0 power, we can just cross out. Put it down here. We got 2x to the negative 1 power, y to the 3rd power to the 3. And on the bottom, I got x, y to the negative 2 power. And then, next thing I do, distribute, all right? First thing I always do, all right? Distribute, get rid of parentheses. Distribute this out here, all right, to every base, including the number out front. It will turn into 2 cubed times x, negative 1 times 3 turns into x to the negative 3 power. Y 3 times 3 gives me y to the 9th power, all over x to y to the negative power, okay? Now what I'm going to do here, now it doesn't explicitly say this up here, but what I'm going to end up doing is I'm going to move all of my negative exponents. Once I get to the point where I'm done with my 0 exponents, done with my distribution, I'm going to move all of my negative exponents to the top, to wherever they need to go. So any negative exponent that I have on the bottom moves to the top. Any negative exponent that I have on the top moves to the bottom. And then it turns into 2 cubed y to the 9th, and then y to the 2nd turns positive, over, I'd move this x to the 3 to the negative 3 to the bottom, turns into x cubed on bottom times x squared. No, just x, excuse me, okay? And then from there, and I'm going to erase this to work out actually this will be the last example that we work on. And then after that, what we're going to do is we're going to combine the top parts here. Now remember, this is all multiplication on top here. So if I'm multiplying these bases, remember, we add those exponents. Same down here, we're going to add these exponents. X to the no power is x to the 1 power. So if we do add these exponents, y to the 9th times y to the 2nd turns into, and 2 cubed is automatically 8, turns into y to the 11th, 9 plus 2 equals 11, over x to the 3rd times x to the 1st. We just add those exponents, 3 plus x to the 4th power, because 3 plus 1 gets you 4, okay? All right, so those are the few examples that we've worked on. So that's just a quick, bigger example there. I'll probably make another video working through some of these other examples in just a second. Other than that, these are the 7.2 notes. Thank you guys for watching them, and I will have the 7.3 notes out also soon as well.